A very good day. We are from Group A3. Today we are going to present about the comparison among different categories and example of operating systems. Here are our group members, Chu Xinjie, Chia Jianing, Chiang Ho Lei, Wang Weizhe, and each of us were involved in each part in this presentation. First of all, I would like to introduce myself. My name is Chu Xinjie. Matrix number is 164517. I and Jianing will explain the question 1, which is explain how embedded OS, network OS, and regular desktop OS are different from each other, with emphasis on general features. Before I begin, I will just briefly explain what are embedded OS, network OS, and regular desktop OS. Embedded OS is an operating system designed to perform a specific task within an embedded system. It's generally smaller and it focuses on efficient operation and dedicated functionality only. Network OS is a specialized operating system that allows devices and computers to connect and share resources on the network. It facilitates communication and resources sharing across a network. Regular desktop OS is the environment where the user controls a personal computer. It functions as a bridge between programs and the computer hardware. It can support a wide range of applications and tasks on personal computers. Now let's talk about their differences. Firstly, they are different in their storage capacity. For embedded OS, it has limited storage capacity. This is because embedded systems are usually small. Physical space is the major constraint on the kind of memory that can be used, so it tailors for efficient storage utilizations due to its limited resources. Generally, network OS has larger storage capacity due to their role in managing resources and data across multiple connected devices. As the number of network devices increases, there rise a problem called scaling challenges, because there is a growing demand for storage capacity to accommodate the data generated. Desktop OS has large storage capacity as it is designed to handle large amounts of user data, applications, and multimedia files. But at the same time, desktop OS also face fragmentation issues, which are the external and internal fragmentations that will impact the overall storage efficiency. Next, I will talk about their security. Embedded OS is more secure than network OS and desktop OS. This is because it is designed to perform specific functions only and do not have unnecessary components that can be exploited, so they are more stable and resistant to external threats. Network OS is facing security challenges due to their large amounts of data, functions, and users. To overcome this problem, Network OS has provided some measure of security to protect the network from unauthorized access. For example, user authentications, access controls, and data encryptions to protect the network resources. Desktop OS is more vulnerable to security threats since it has wider range of functions and are used by a larger number of people, but the users can choose to upgrade their security level by installing antivirus software and upgrades their security system regularly. Now I will pass to Jianing to continue explain the rest of the differences for these three operating systems.
So thank you Xinjie for your explanations. A good day to doctor. I'm Chia Jianing, matrix number 164328, and we'll be continuing question 1. So for another notable distinction between different OS lies in their size and complexity. First and foremost, for the embedded OS are generally the smallest and least complex among the three types of OS. This is because they are designed to perform specific functions. For instance, ATM focuses on user identification, money withdrawal, and also the balance checking. While in contrast, network OS are moderately sized and complex. This is because they prioritize on communication capabilities by incorporating comprehensive stacks for the management of network protocols. This including the tasks such as creating, exchanging, and decomposing network packets to ensure an efficient communication within a network environment. Meanwhile, for regular desktop OS are the largest and most complex. This is due to their features-rich environments to support a wide range of applications and also functions. This includes controlling laptops, desktop, and also PC. So in short, this is an overview of the comparison for size and complexity. So moving next, we will now contrast on their user interface. Firstly, for the embedded OS typically features the most straightforward and simplest user interface, often displaying a few buttons or touchscreen for user interaction. So for example, ATMs will allow users to select options through a touchscreen and buttons for further interaction. While on the other hand, a network OS generally have a moderate level of complexity in the user interface. This complexity is designed to help administrators in managing various networking tasks and auditing tools. For instance, network administrators use command line interface to configure routers, switches, firewalls, and other networking devices. While in contrast, a regular desktop OS usually has the most complex user interface, which is the graphical user interface that acts as an interaction point between the hardware and also software. For example, it will allow you to use your mouse to click on icons, buttons, and menus, and everything will be clearly displayed on the screen using a combination of graphic and text. So, in short, this is an overview of the comparison for the user interface. Last but not least, we will now contrast the hardware requirements for different OS. So firstly, for the embedded OS is actually designed to work with specific hardware configuration, and the software and hardware are often tightly integrated. So for example, once developed, an embedded OS typically is lacking of the flexibility for changes, improvement, or upgrades. While in contrast, network OS is designed to be adaptable and compatible with various hardware and new technology. This is to ensure the scalability and efficiency in managing diverse networking environments. So, for example, the network can be easily upgraded with new technology and also hardware implementations. While for the regular desktop OS are actually designed to work with a wide range of hardware configuration to ensure the efficiency of different types of hardware including laptops and desktop. So an example is that the Microsoft Windows, which runs similarly on various computer systems from high-performance gaming desktop to lightweight laptop. So in short, this is also an overview for the comparison for the hardware requirement of different OS. So last but not least, I will now pass the stage to my group member Hole to continue to the question 2.
Hello, I'm Chang Hole with matrix number 163715. I'll be presenting for part 2, which is to describe and compare at least 2 actual embedded OSs with emphasis on embedded features. Actual embedded OSs that are chosen to be compared are embedded Linux and FreeRTOS. So, what is embedded Linux and FreeRTOS? Embedded Linux is a type of Linux kernel used in embedded devices such as Android and complex system application development, as it supports multi-threading, networking, file system, and it has a rich set of user space libraries. On the other hand, FreeRTOS is a real-time kernel designed for embedded systems and provides a multitasking environment that allows developers to create applications with real-time constraints. Next, I'll be presenting the comparison between both tools in terms of features such as memory management, real-time functionalities, and file support. In terms of memory management, embedded Linux requires MMU, while FreeRTOS does not require MMU. MMU is defined as Memory Management Systems, which is the computer hardware that handles memory and operations with processors. The reason why embedded Linux requires MMU is because it is designed to support a wider range of applications and systems that require multitasking, memory protections, and dynamic memory allocations. On the other hand, FreeRTOS is more to simplicity, efficiency, and deterministic real-time behavior, and since it optimizes such features, it prioritizes more on small memory footprints and direct access to physical memory. With MMU in embedded Linux, you have a better memory management, protections, and making it more beneficial for complex programs compared to FreeRTOS. Next, in terms of real-time functionalities, which is defined as systems that perform real-time applications functions and all the activities are predictable and has a specific time constraint. Embedded Linux has a poor real-time functionalities because it comes with rich sets of features that often focus more on the overall device performance, and hence, it will require more time to complete each program. On the other hand, FreeRTOS has strong real-time functionalities because it prioritizes more on the predictability, making all the tasks within it to be completed in each fixed period. FreeRTOS could accomplish this by utilizing priority-based scheduler that keeps tracks and ensures tasks are completed. Example of systems that implement FreeRTOS is avionics systems that are used for flight control systems and navigations. Last but not least is in terms of file system support. Embedded Linux could be used with a number of file systems through virtual file systems and thus allowing users to choose the most suitable file system types for embedded applications. Examples are such as CrimFS, JFFS2, and ext2. Meanwhile, FreeRTOS does not have file system support due to its developing purpose as a minimalist real-time operating system, and hence, it does not require file systems that are mainly for general-purpose operating systems. If it is required, external libraries could be integrated into FreeRTOS for these features. So, that's all for my presentations on embedded operating systems. Next, I'll be passing to my groupmate, Wang Weize, to continue the presentations on embedded network. Thank you.
Thank you, Holly. My name is Wang Weize with the matrix number of 164825. I'll be continuing for part 3, which is describe and compare at least 2 actual network OS with emphasis on networking features. There are a lot of types of network OS. However, today we are going to compare only just 2 network OS, which is Microsoft Windows servers and Linux Ubuntu server. First of all, I would like to describe about the functions of each networking operating system we have now. For Microsoft Windows servers, it is used to handle administrative group-related activities, such as organizing the file, and perform the function such as storage, senders, receiver from devices connected to a network. However, for Linux, which is our Ubuntu server, it is a network operating system for routers, switches, domain name system servers, and also the home networking devices. Because it is due to its networking capabilities. It includes the support for routing protocols and network bridging, make it suitable for all these devices. For networking features-wise, the Microsoft Windows servers has the built-in support for Active Directory, which allows the centralized management of user accounts and permissions. The networking is based on NetBIOS protocol and also the SMB file sharing protocol. However, for Linux, our Ubuntu servers, it uses the AP directory system and its networking is based on TCP or IP protocol and NFS file sharing protocol. Next, I would like to compare about the integration for each of the networking operating system we have now. For Microsoft Windows Server, it has a better integration as compared to Linux because it can integrate better with Microsoft product, such as the 2 of the database shown below, which is Microsoft's SQL Server and also the Microsoft Access. Both of them can only be run using Windows servers. However, for Linux, which is our Ubuntu servers, it has lesser integration because it is more complicated and requires a lot of work. The database as represented is MySQL and also PostgreSQL. However, you will need to have extra steps to download it into your Linux. So one question is that, which network OS is easier to use? So in this case, Microsoft Windows servers is much more beginner-friendly than Linux, as it has a remote desktop, which is an easier way for them to manage a server, as it comes with a graphical user interface, which is GUI. However, for Linux, it is less beginner-friendly because it uses command line interface, either through SSH or console. It's harder to learn for the users. However, in terms of reliability, Microsoft Windows servers is less reliable than Linux because it has potential security vulnerabilities, as Windows has a larger attack surface compared to Linux. For example, PowerShell from Microsoft is not stable. However, for Linux, it is more reliable because it uses fewer resources, making the system more efficient, and then the lower resource consumption means improved performance, lower infrastructure requirements. It does not sustain memory leaks as frequently, and only require reboot when the kernel update is required. Finally, we have our last comparison, which is for flexibility. For Windows servers, it requires more waiting time because it needs the new version of the Windows servers to be released, only it can make changes. However, for Linux, it requires lesser waiting time because it can modify on the fly without waiting, and it is great advantage when a security breach is detected. Alright, this comes to the end of the part 3 and also the presentation as well. Thank you for listening and have a nice day.